In this lesson, we'll take a closer look at the program elements used to define, interface, and connect a Dynamo definition to a Revit document. Before working in Dynamo, we'll have to make several decisions about whether the definition is for a project or family document. For instance, if you are looking to automate the placement of Revit families or manipulate project parameters, you'll want to launch a new project document. If you are intending to create a new conceptual mass, the family environment is better suited. We are going to be placing reference points, which can only be done in the mass environment. Therefore, we will create a new Revit conceptual mass to get started. Open the default mass template. After loading the family document, I'm going to browse to the Add-ins tab and launch Dynamo. Let's maximize the window for now as well. Use the search toolbar on the left-hand side of the workspace to locate the number node. The number node allows you to define either a number or integer value by clicking in the text field. You can give the number a new name by double-clicking and selecting Rename Node. This allows you to more clearly indicate what the node is being used for. Let's go ahead and rename this node Origin. Again, I will use the search bar and locate the point by coordinates node. Type in XYZ and browse the results. Alternatively, you can browse through the library from Geometry to Point and select the appropriate node. You will notice that there are two bi-coordinate nodes. You can hover over each node to compare the differences. We are looking for the third option based on the input comparison of the node we found using the search feature. Nodes are building blocks of Dynamo definitions and represent a variety of automation routines such as creating Revit elements or performing math operations. Nodes have inputs and outputs referred to as ports. Inputs are on the left side of the node, outputs are on the right side of the node. Data flows through the ports from left to right. Ports require specific types of data. In this case of the point node, the XYZ ports require a double, which we can verify by hovering over the input ports. Passing data other than this type will result in an error. To connect the number node, left-click on the node output, move over to the X-coordinate input node, and left-click once more. You do not need to click and drag. Let's repeat this process to define the Y and Z. Wires appear as dash while being dragged and solid once successfully connected. To disconnect the wire, left-click on the output node, move your mouse to the free workspace and click once more to release the wire. With this action, we have created a relationship between the number and point node. Data is able to flow downstream from one node to the next. To view the output of the XYZ node, I will use a watch node. Again, I will type into the search field in the library. The watch node is a unique Dynamo object that allows you to inspect the current status of a node by viewing the output port data. The watch node belongs to a unique Dynamo set of elements located in the core library, which again can be located on the left. Let's connect the output point to the input watch node. Make sure the script is set to run on the bottom left corner to begin flowing data. By changing the value in the number node, we can see that the X and Y values of our point coordinate have changed. By selecting the number node and going to Edit, Copy, Paste, we can duplicate the selected node as well as the existing values. This can also be accomplished with Ctrl-C and Ctrl-V. Connect the new number node to the Z input. We can then change the value and verify that it is updated in our watch node. To have a more dynamic user experience as our definition develops, in the search field, let's go ahead and type slider. This will reveal two nodes, a number slider and an integer slider. Click both options to bring them into the workspace. The slider is a unique user object. It allows you to interact with the numbers using a defined range. Using the drop-down at the bottom left corner of the node, we can see that this range is defined by a minimum and maximum value. We will change the maximum value to 20. The min and max values can then be collapsed. Notice that the number slider, sometimes referred to as the double slider, will return a floating value, where the integer slider will only return whole numbers. Let's use the number slider to define our Z coordinate and delete the integer slider by selecting it and hitting the delete key. Connect the number slider to the Z input on the point by coordinates node to replace the existing connection. As we begin to make changes to the slider, notice how the watch node dynamically updates. Let's turn on the background 3D preview by going to the View tab and selecting Background 3D Preview and clicking Show Background Preview. To navigate the background 3D preview, use the geometry icon in the lower right-hand corner. To return to the definition, use the graph viewing icon in the bottom right corner. As I make changes to the Z coordinate, you will see the changes update dynamically in the watch and background 3D preview. Alternatively, you can turn our background 3D preview off and search for the watch 3D node in the library. Add the node to the canvas and connect the point by coordinates output node to the watch 3D input. Similar to the background 3D preview, you can navigate the watch 3D by clicking inside the window. It can also be resized by dragging the tab in the bottom right corner of the node. Sometimes it may be helpful to move the watch 3D node under the slider to visually track actions. It is important to note that what we were seeing in the watch 3D node exists natively within Dynamo and not within Revit. If we restore the Dynamo window, we can position the Revit and Dynamo windows side by side to better help visualize the workflow. Points in Dynamo represent a zero-dimensional intersection in space at the specified coordinate, meaning that the XYZ node is an abstract coordinate, not actual geometry. To create actual Revit geometry, let's search for point in the library. As we scroll through the results, we will notice that there are a number of point-related nodes. Here under Revit, we find a subcategory for elements. With elements, we can create a reference point in Revit by either coordinate or by points. Choose the reference point by point node, and let's connect our point coordinate output to our reference point by point input. In doing so, we see that the reference point by point node will create a fully featured Revit element. It is important to note that this reference point can be used just as any other reference point created in Revit. Let's draw a spline by selecting the Spline Through Points tool in the Revit Draw subtab. By clicking in the viewport, I will define a few points followed by our Dynamo point. Notice as I move my mouse pointer near this point, Revit will automatically snap. I will continue to define a few more points and then hit the Escape key to exit the spline command. As we make changes to the point in Dynamo, you will see the spline in Revit is now updating dynamically. Coupling the parametric capabilities of Revit alongside the visual programming environment in Dynamo creates a unique feature set for working with computational design within a building information modeling environment.